So let's do some problems involving looking at the unit circle and the properties of the unit circle. So these questions are often tricky because we have to look at a lot of possible lengths and think about some different triangles and whatnot. So the key fact here that we're going to use is that points on the unit circle are cosine theta comma sine theta. So any point on the unit circle, x comma y, the x-coordinate of that point is going to be equal to the cosine of the angle in standard position, and the y value of that coordinate will be equal to the sine of the angle. So let's do this problem. Which coordinates are equal to the sine of pi over 5? So first, let's find this angle pi over 5 in standard position over in the picture here. So remember, starting at 0 radians would be right here on the unit circle. And then moving pi over 5 would put us to point B. So that is the angle pi over 5 in standard position. Now notice the problem says that each of the marked angles is pi over 5 radians, meaning this is pi over 5 radians, this is pi over 5, all four of these marked angles are pi over 5. However, if I'm thinking of pi over 5 in standard position, I'd be starting at the point 1, 0 and moving pi over 5 radians counterclockwise, putting me at point B. So definitely the sine of pi over 5, it's definitely, if I'm landing right here at point B, it's definitely the y value of point B. Because that's the definition, sort of how the unit circle works here. That if I'm at this point B right here, this y value, that is the sine of that angle in standard position. So now the tricky part here, though, is that are there any other lengths in the picture that are the same length as the y value of point B? So looking at this, I'm thinking, I think there is, because look at the y value of point A. That's definitely bigger. The y value of point A is bigger than the y value of point B, so it's definitely not the y value of point A. But look at this. Look at the x value for point A. That right there is the same distance as the y value for point B, and both of those are positive. Notice the y value for point B is positive. The x value for point A is positive. So I'm thinking points in quadrant 1, the x value and the y value are both positive. Points in quadrant 2, the x value is negative, the y value is still. Points in quadrant 3, the x and the y values are both negative. And points in quadrant 4, the x value is positive and the y value is negative. So notice here for point C, the y value for point C, it's the same size as the y value for point B, but the y value for point C would be negative. So that's not a choice. But look at point D here. Look at the x value for point D. Look at the x value for point D. That's the same as the x value for point A. That's also the same as the y value for point B, and they're all positive. So there's sort of three answers here. So the sine of pi over 5 equals the y value of point B, the x value of point A, and the x value of point D. So these problems are very, very difficult because when you're thinking of any point on the unit circle, the x value of the coordinate is the cosine and the y value is the sine. But like as you see here, like point B, the y value for point B, that'll be equal to the x value of some different points on the unit circle. So see how point A, the x value for point A is the same as the y value for point B, and then the x value for point D is also the same as y value for point B. All those three red lines I've drawn there, they're all the same length and they're all positive, sort of in the positive direction. These problems are pretty tricky. So let's look at this here. So now we want to figure out which of these trigonometric expressions, and selecting all that apply. So it could be none, it could be all of them, it could be one or two of them. We got to figure it out. Which of them equal the y coordinate of point A? So here's point A. So which of these equals the y coordinate of point A? Well, definitely the y coordinate of point A is the sine of the angle. So definitely we can say that whatever the angle is, the sine of, the angle is 1 3/4 pi. So the sine of 1 3/4 pi is the y coordinate. Of point A. But now looking, that's not one of the choices. So now I've got to get a little bit clever. Notice all these angles are bigger than 1 3/4 pi. So sort of the concept that this problem is testing is that if I'm at this point on the unit circle, that's from standard position all the way around to here, 1 3/4 pi. So if I go around another 2 pi, I would wind back up right where I left off. So if I kept my angle going another 2 pi, I'd wind back up at point A. So what would that angle be? If I was at 1 3/4 pi and I went another 2 pi, that would bring me to 3 3/4 pi. So 1 3/4 pi and 3 3/4 pi, they're the same angle. So from standard position, I would land at point A in both cases. So the sine of 3 3/4 pi is the same as the sine in 1 3/4 pi. Both of those are the y value of point A. So definitely that is one of my answers. Then I could apply the same logic. I could go around 2 pi again, and I would land at 5 3/4 pi. So both of those angles, 5 3/4 pi, 3 3/4 pi, are coterminal with 1 3/4 pi. So now what about these other two choices? Let me just clean up the diagram here a little bit. So these other choices, okay, 4 3/4 pi. So okay, we went around 1 3/4, and then 2 more pi gives us 3 3/4, and then if we go 1 more pi, we would land over here. So the question is, if we landed over here, would the y value of this coordinate be the same as the y value of point A? And it would not, because this y value is positive for this point. The y value for point A, negative. So they're the same sort of size. So these red segments I'm drawing here, perpendicular to the x-axis, are the same size. But remember, in quadrant 2, x values are negative, y values are positive. So this y value would be positive. The y value for A is negative, because points in quadrant 4, the x value is positive, the y value is negative. So it's not going to be this first choice, and then it's not going to be the second choice, sort of by similar logic, because if we moved around 2 3/4 pi, so from standard position there's 1 3/4 pi, so 2 3/4 pi, boom, would put us right there in that same spot. So those are not choices. So we've got two answers to that question. So questions are really tricky because you have to think of angles that are coterminal to the angles that you're given, and you really have to think about the geometry of the unit circle.